For question 2, part A, you are given a slab of 1 meters times 4 meters on plane, and you are also given the fact that the slab is supported by 2 beams along the edges, and the beams of course are supported by something else. Let's say you have 4 columns right at the corners. So if you have 2 beams along the 2 long edges and no beams along the short edge, the slab will just bend along the shorter direction and no bending in the other direction, and that's why this is called a one-way slab. And to find out or to determine the number of rebars for this concrete slab, it's easy. What you need to do is to apply what you learned from beam bending. So you know that the bending, it's along this direction. So you cut the section here. Let's say this is your section AA. So section AA looks something like this. And then that length is just 1 meter. And you can treat this as a beam supported by the 2 beams at both ends, just like a simply supported ends with 2 pin supports. Okay, and then the beam will bend like this in sacking. So the question is, you first of all have to find out the bending moment at the critical location. In this case, it's at the center of the beam. So first of all, you find out the self-weight of your beam, which is given by the density of concrete, 25 kilonewton per meter cube, times the cross-section area of this beam. Okay, so you cut a section here. Let's say this is your section BB. And make sure you can draw section BB. So section BB looks something like this. This is section BB, which is 4 meters long and 0.15 meters thick. So this 25 kilonewton per meter cube times the cross-section area will give you the self-weight acting on the beam in the unit of kilonewton per meter. By the same token, you can find out the live load, which is given in the question sheet as 5 kilonewton per meter square, and then you multiply. Remember, this 5 kilonewton per meter square is applying at the top of the slab. Okay, so if you multiply by the width of the cross section, that will give you 20 kilonewton per meter length along this beam. So the self-weight is 15 kilonewton per meter and live load is 20, or in other words, the total load is simply 35 kilonewton per meter. And then based on that, you know this is just a beam and supported at both ends, and you have 35 kilonewton per meter of loading acting on the top. So you can easily find out the bending moment at the center. And the detailed procedure I'm not going to repeat because you should have done it a long time ago. So I just write down the bending moment at center is simply equal to 4.38 kilonewton meter, and this is a sacking moment. Well, that means the tension is at the top, is at the bottom. So the reinforcements will be placed at the bottom of the slab. And then to find out the number of reinforcement required at the bottom of the slab, you simply calculate or equate this moment, changing it to the units of Newton millimeters, so that will be times 10 to the power 6. And on the right hand side, you will have the tensile strength of reinforcement times the number of bars times, let's say you are using T10, diameter 10, so that the area of each rebar is 10 square pi d square over 4. So that will give you the total tension force in the reinforcement times the internal lever arm, which is 0.75 times the height of the cross section, which is 0.15 meters, and you change it to a unit of millimeters, so that's 150. And from this equation, you can find out the number of rebars is only 1.08, or round up to 2. That means you only need 2 numbers of. And of course, in this example, the number of reinforcement looks not very reasonable. Okay, so if in practice the span of the slab is a bit longer, then the number of reinforcing bars that you need to provide is a lot more than just 2 T10. And make sure you know that these reinforcements are arranged in this direction on plan, and in the cross section that should be placed close to the bottom of your slab, because this slab is under sacking, so the tension is at the bottom and it's bending in this direction, so the reinforcements are arranged in this shorter direction.